Hey guys, how are you guys doing? My name is Harold Serrano and I develop game engines for fun. I hope you had a good weekend. I know it's Sunday, it's almost over. Uh, let's see, everything's ready to go. All right, so what I want to do today is basically fix an issue that I have with that the engine is having with the camera. Um, there's something going on with the interpolation, and it's not the camera motion is not smooth enough. Uh, so what I want to that's what I want to fix today. I don't think it's gonna be a long stream, probably like about an hour, but that's good enough. Um, Aside from that, let me give you some announcements that I so you know. So a group of indie game engine developers and myself, we decided to start a Discord, um, basically to support one another, um, with our desire to develop a game engine. We started a Discord, which if you are an aspiring game engine developer and you want to be part of our group, so you can, get some tips, guidance, and have access to resources that you may need and that you will actually need, not that you may need it, you will need it. Um, join our Discord. The link can be found in my Twitch channel information. So, join us. Right now, we're about 20 of us, 19 last time I checked. Uh, but it's gonna be fun. We're gonna be sharing tips, guidance, ask questions, share your devlogs, anything about game engine, you know, post it in our Discord channel. All right, guys. So let's get ready to work. Let me go to my code, and let me bring up. So what I'm gonna do, basically, this is our little astronaut, and we have. I'm gonna get rid of the pistol for now. So we have the astronaut, and we have this plane. And what I'm gonna show you is that when the astronaut goes up the hill, the motion of the camera is not smooth enough, and that's what I need to fix. All right. And actually, yesterday I spent most of the day actually thinking about how to fix it. Uh, I tried different implementations. As you know, I was just testing them out because I didn't know what was the real problem, and it took me a long time to figure out the problem. And the solution was actually is actually very simple. But it was I was up, since like around I think like 7 a.m. Yeah, I woke up at 7 a.m. I tried some implementations. I did some linear interpolations. I did some spherical interpolations with quaternions. None of them really worked. Then I went to play soccer. I came back, ate lunch, and kept at it. And it was not like until 5 p.m. That it clicked on me. I'm like, what if I do it something else? And that's what I'm gonna show you. It turns out that the solution is quite simple. It's actually, and it works beautifully. All right. So before we start, let me load all of this. Let me load up the characters. I'm gonna export the characters to the engine. So it should be here. Boom, that's that. I'm gonna bring up my Xcode, and on Earth, the class Earth, I'm going to basically include my some header files that I need. All right. Basically, these are the header files for my character. So let me declare them. Let me declare a pointer. My astronaut here. Okay, I think that's what I need here. And over here, let's do that. So my astronaut. You know what? Let me give me a second because There you go. Cool. New U4D game object. Oh no, I'm sorry. Oh no. This is of type astronaut. Astronaut. All right, now what I'm gonna do is I'm gonna do my astronaut, and I'm going to basically load all of the textures and the vertices and normal vectors which we got from here into the game object. So I'm gonna call init, and how I do this basically is I just provide the name of the character, which in this case it happens to be astronaut, and then I provide the name of the file that I actually store that contains the data, and the file that contains the data is astronaut attributes. All right, so that U4D. And if all of that is okay, what I do now, I just need to so let me make sure. When I go into the init method, it loads the shadows. It does the animation loading. All right, so all what I do here, I'm just going to add my astronaut to my scene graph. My astronaut. All right. The other thing that I'm going to do is also I'm going to load up this plane here. So what I'm going to do, I'm just going to do a U4D engine game object. I'm sorry, and call it my plane, and do U4D game object. And here, what I'm going to do, basically I'm going to do the same thing. If my plane load model, and then I'm going to give it a name, which should be plane, and also that file that data is found in. So astronaut attributes that U4D. Now you may be wondering, why do I use a different method for this different objects? Well, basically the init method that I implemented for my astronaut already, it does the same thing what I'm doing for the plane. It does if load model, which is the same method here. Okay, so if everything goes well, I need to, number one, load the rendering information. So basically this method will send the data to the GPU. I also want to enable set shadows, so enable shadow, and I'm gonna make it to true, set it to true. Since I want the characters to be, since I want my astronaut to be able to go up and down the hill, I need to also create an org tree that will contain all of that data. And I don't want to go into details on how that works, but in my previous videos that you can find on my YouTube channel, actually I explained how that works. All right, so I don't want to explain that because it's going to take a while. So my plane, and here said, let me recall the method here that I need to use. Objects, and that should be under static. Enable mesh manager, right? That's what it is. So I need to say, and I need to write documentation to the new features that I'm adding, because enable mesh manager, because some of these methods, they need to go before I send the data to the GPU. So enable mesh manager, and I need to provide a subdivision. So I'm going to provide a subdivision of 2. That should be good enough. Basically, that's subdivision for the arc-tree, right? If you set it to 1 subdivision, you're going to create 9 nodes. With a subdivision of 2, you create 73. I think with 2 it should be enough. All right. So my enable mesh manager, load rendering information. That should be okay. All right. And once we're done with this, we need to add this guy to my scene graph, so my plane. All right. So let's hope that that works. All right, so it's building. And is there anything else I wanted to share with you about any announcements? No. Aside from that Discord channel that we created, that's all what I have for this week. All right, guys. This is taking a little bit too long to build, and I wonder why. Oh, there you go. All right, so let's do a quick test just to see that everything works before we move on and enable the first person camera and the third person camera. All right, so I'm gonna build this, and I'm gonna move the character with my controller here. All right, so let me build this, and I'm going to change screens right now. So, and everything seems to be building fine. Everything's being loaded fine. All right, so we should see something right now, and there it is. All right, so let's just do a quick test. If I move that way, that my character should go up the hill. There you go, perfect. All right, cool. If I come down, everything should be fine. Cool. All right, so now what I'm going to do is I'm actually going to enable my first person camera. Right now, what camera that I'm using is the basic one. All right, so let me bring up my I'm gonna go to my documentation. So, and what I'm gonna do, I'm just gonna copy how you create a command. There you go. Oh, that's interesting. If I just was hoping that if you, all right. So I'm gonna go to my camera sections. And like I mentioned, the Untold engine basically provides 3 different type of cameras. Has a third-person camera, which behaves like this. It has a first-person camera that basically, you get to see the whole world from the perspective of the 3D character. And then we have the basic follow camera, which just follows the character. All right, so what I'm going to do, I'm actually going to, first of all, I'm going to test out the first person camera so you can see the problem yourself, all right? So I'm going to just copy this. And I'm going to include this here. And I need to change the name of the object here. So basically what I do here is, first of all, I instantiate the camera object. My camera is basically a singleton. There's only one camera in a game, and I do that by declaring the camera as a singleton. Next, what I do, I create the type of camera that I want. In this case, I want a first person camera, right? Then I basically set the parameters that I want, like the offset, and then I set the behavior to the camera of the camera. All right, so before we move on, I need to actually include some headers. So if for the camera interface is one of them, include that, and the other header that I need to include is the first person camera. All right, okay, now let me make sure that the offset is actually quite what we want. All right, so I'm gonna move my pointer here. And I want to actually get a sense of where it is at. So 0.5 is that's where I have it. I can actually go to 0.4 and 0.6. So the offset could be actually be 0.6 and 0.35. Let's check that out. 0.6 and 0.35. Let's see if that works. All right, so basically what I want to do, I want to set that camera offset right here in this location that I'm pointing with my mouse. All right, so let's build this and see what happens. Come on. I don't know why it's taking so long to build it today. Okay, so as you can see here, this is my output window. And that's basically saying everything that's going on at, like for example, it's loading the attributes, it's loading the files, it's creating the objects, it's loading the animations, etc., etc., etc. All right. So as you can see here, what's going on is that we are not able to see what's happening because of the offset. So I'm going to set it back to 0.5. All right, and I'm going to build this again. And right now we should see something showing up. All right, so should be coming up. You know, it's amazing how when you're actually live streaming, how time actually flies. I've been live already for about 19 minutes, and it doesn't feel like so. So it's interesting. It's just weird. All right, so here's what we have. And as I moved my character, you could see, you know, I'm seeing everything from the first person, from the camera perspective, right? Now I'm going to show you what's going on with the camera, right? When I go up this hill, the camera is not, the motion of the camera is not smooth enough. It's kind of choppy as I go up the hill, and you're going to see what I mean. You see that? It's insanely choppy. So that is not good at all, right? And that's what I actually want to work on. All right. And I actually thought that this was going to be like something very simple to fix. And it is simple to fix. I just took me a while to figure out what's going on. All right. So let me show you what's going on. All right. Let me bring up my sketchbook here. Let me get this ready over here. I'm gonna move over here so you guys can see that, and over here. Let me move my keyboard. All right. So the problem is that we have our character, right? And as it works on the flat plane, right? The his view direction is flat, right? So I'm gonna call it like that. Okay. I wonder if you guys can actually see that. Is this the size? I want to make sure that you guys can actually see it. Okay, right. So now when the character actually is going up a slope, right? The view direction changes all of a sudden from basically flat to a particular angle, right? The camera that I have implemented, what happens is that the camera doesn't change direction smoothly, right? It just changes from one direction to the other, and that's why we see the choppiness of the camera. That's why the camera motion is not smooth enough, right? So what I was thinking of doing initially was like, well, why don't we interpolate, right? We can interpolate this and somehow get a new view direction. Sorry. That can actually help with all of that, right? So we get a new interpolation, and that should fix it. Well, it doesn't really fix the problem, because if there is if there's like a huge change in the direction, right? So this is my view direction 1 and view direction 2. If there's a huge change in direction, if I interpolate it, I'm gonna get my new vector, which should be something here, right? So the choppiness is still going on. Like, no matter how much you interpolate this, it doesn't really fix it, right? And I tried doing the linear interpolation, I tried to do the spherical interpolation, and none of that helped, right? And at one point, I actually was thinking of re-implementing the whole camera system, starting from scratch, from zero, because I'm like, what's going on? And then it occurred to me to do something which is called the recessive weighted average, right? Ideally, what we want is something like this, right? This is my view direction 1, this is my view direction 2, right? What we really want is to have this motion slowly changing. All of these are my view directions, right? Slowly changing from one position to the other, right? So what it occurred to me is like, hey, why don't I store my previous values of my view direction and store like about 10 of them or 20 of them, then do an average of that view direction and apply it to the camera. And as I get a new value, a new direction coming in, I will again store that new value, average it out with the previous values, and set the camera direction to that average, right? So I'm like, that may actually help, and that's can actually work, and that's some kind of interpolation in a way, right? And then I came across, I was reading this book, Game Physics for Developers, and the guy mentioned that there is this function called recessive. Hold on, where is it? Let's see. Recency. I'm sorry. It's called recency. Weighted average. All right. And basically, that's, I'm reading some notes here. Basically, what it does is it gives an average of the last few values, with more recent values being more significant, right? And the whole function, the equation is like this. So this is my recency weighted average, which is equals to bias times my plus 1 minus my bias here times my new value, right? So that, right? So basically how it works is that the bias parameter, it controls how much significance is given to the previous value, and a bias of 0 makes the average equals to the new value each time it is updated, and a bias of 1 ignores the new values altogether, right? So I actually used this this equation in the physics engine, right? To basically control the kinetic energy of my object, right? And somehow, I was watching TV, Netflix, and it occurred to me, hey, there is an equation, right, that can actually help me with the whole weighted average, and this was it. So we're going to implement this equation, and we'll see how that helps. Cool. All right. So give me 1 second. Okay. Let me bring up Xcode. Let me move this to the side. Okay, so I'm gonna do these changes in my camera. Where's my camera? Camera. Here it is. And I'm gonna go to my first person. All right. So basically what we need to do, we need to implement a function that does this. We need to provide a bias here. Hold on, before we do anything, any cool stuff, let's see, let me show you if it works. All right. So there's a problem here. Translate the camera. This should actually go to the end. Any rotations should always go before any translations. So okay, so keep that in mind, because I have had issues in the past. All right, so this is the section that we need to fix, the view direction of the camera. All right, so I think I know what I'm gonna do. So what I'm gonna do right now is basically I'm going to declare a 3D vector, and we're gonna call that accumulator. All right. So basically that's going to accumulate our the whole average. Then we're gonna have a bias, right? And we're gonna set the bias to somewhere around like 0.98. All right. Um, and so it's gonna be our bias here times our accumulator plus 1 minus bias times my new view direction. Alright, so it's gonna be accumulator, bias, blah blah blah. No, since these are interfaces, I'm thinking what we should do is set it here. Let me see, where can I put this? Include E for the vector 3n.h. Right, and I want to put the accumulator here. U for the vector 3n accumulator. Right. That's gonna be my accumulator. Now what I want is do that. By the way, my all of my camera types are actually also singletons. Just so you know. Alright, so here's what I'm gonna do the whole magic. So I'm gonna do accumulator equals my bias, and for now let's just do this. Float bias equals 2.98. I'm gonna fix it in a second. Alright, so it's gonna be accumulator times bias plus let me bring this guy private protected. Alright, so that way I can use it. Okay, and this is gonna be my model view direction times 1 minus bias. And let's see. Yeah, that's what I want. Cool. Okay, so my accumulator is going to be accumulating my direction and on, stuff like that. Alright, so I'm gonna do something else here, and I'm gonna go for the vector 3n new camera direction, and I'm gonna put this set the values to that, and I'm gonna do this because I've realized that I need to somehow whatever view direction I get, I need to multiply it by a large value to keep the model looking into the distance. Now I think I may have to fix that in the future because I actually do not like that, but for now I think it's okay. So so basically I'm setting my new camera direction to be the same value as that my accumulator. All right, and I'm gonna do that. So now with this, what I should get, I should actually get the camera direction. Alright, let's give it a shot. Let me build this. Hopefully everything looks good. I may need to declare a new method that allows the users to set the bias for the camera. Um, I set it to 0.98, but the game developer may want to set it at a different level depending on his game. So let's see. And actually how I have it, I don't like it how I have it. That's right. I don't like that thing. Okay, what's my error? I have a semantic issue. What is it? Alright. Yes, you know what? I don't know about this guy right here, actually, to be honest with you. This is an interface, okay, that's a problem. So I'm gonna put it here. Probably I fix it later. Back to the 3n.h. And what I'm gonna do here. I'm gonna set the accumulator there. Alright, let's build this now and let's see what happens. So we'll see. Okay, this is insanely weird. Xcode is taking way too long to build. I wonder if I wonder what it is. I have no idea. Alright, you know what? In the meantime, what I'm gonna be doing is actually this plane right here is not long enough for what I want to test. So I'm gonna delete this plane and I'm gonna create a new plane here. So that way we have this ready. Come on there, where are you at? So let's call this 0, 0, and -1, I think. Now let me move it up. Alright, so I'm gonna set the X direction dimension to 8, and then the Y direction I want to make it actually quite long. There you go, 20. So now let me create some, call it 20, and let's do like 40. Is that good enough? Right now, 20 also. Yeah, I think that's okay. All right. So now I'm just going to create some small hills here. Enable that. Whoa. There you go, that's good enough. Okay, and let me create one more somewhere around here. Alright. Okay. And let me go over here, editing. Let me unwrap this. Pop. So I'm gonna do that. PAL. And let's put it that color. All right. Default. All right. And let me bring this guy over here. Number 4. Okay, cool. So I have that ready. And so right now, I'm gonna test what we did. All right. And I'm gonna use my previous game assets. Okay, not the one that I just created right now. So should be coming up, and it's not going to work. Hold on, guys. I forgot to actually turn on my controller, so. Alright, so here it is. Here we are. Okay, cool. So now I'm gonna move my camera. Now I'm gonna go up the hill, and let's see what happens. All right. So you see now, you see how smooth that was now compared to the one we had it previously. I think it looks better. All right. Now you may be wondering why, when I'm coming down the hill, we get some kind of a blackout. The reason for that is the position of my camera, or where I have it. So I have it like way too close to my character, and I haven't figured out how to really fix that. I mean, not to fix that. That's simple fix. Like, but where to exactly place the camera. And I think there's more to that actually. But one thing that I can actually do is basically, I didn't show you. I didn't show you what I meant. So basically, what I was talking about is that the reason why you see a blackout when we go down the hill is because of the placement of the camera. Right now, I have it somewhere around here, and I don't know like where exactly to place it. I haven't gotten to to find a proper value for that. But one thing that I can do is actually guess what? Let me see if this will work. I'm going to set shader, and let me actually bring up my API because I'm gonna need it. Set shader. Yes. So here my shader, I can actually provide a type of shader that I want, and that shader that I want right now is the non-visible. So it's gonna be vertex non-visible shader. I just need to provide that name. Vertex non-visible shader, and that's for my vertex shader. And then I need to provide that name for the fragment shader, which is non-visible shader. Vertex non-visible shader and fragment non-visible shader. And let's see if that actually helps. It may actually help, so we'll see. All right, so it's building. All right, let's see. I'm here. Now I'm gonna go up the hill, which is good. Now I'm gonna turn around and I'm gonna come back. And there you go. Yeah. It seems that when I'm going down the hill, the camera vision gets blocked by the helmet of the astronaut. Again, I haven't had the time to find the proper location, the proper place where to place the camera for the offset. All right, so let's actually check out how it works with this one, because the next thing that we want to do is actually do something similar for my third-person camera. All right, so I'm gonna export this resources. Okay, that's for that. So oh boy. Okay. All right. Accumulator. I'm gonna come over here. Include a for the vector 3n.h, and basically I'm gonna do the same. I know we can have this in a function, in a method, and I'm gonna do that later on to clean everything up and make it look nicer. But right now, basically, on this Twitch, my whole purpose was actually to share with you what I found. That sometimes doing an interpolation may not work, and whenever you want something, a value to be smoothed out and to take into account previous values, you can actually use this nice equation called recency weighted average, which basically contains a bias and this whole and it's represented with this equation. So I'll clean everything up later on. I don't want to bore you with the little details that sometimes all right, let me see, accumulator, and I'm gonna set this to 0. All right, now here I also have the same problem with my third-person camera. I do, oh no, actually good. I do my translation first, and then I do that. All right. Okay, let's see if we can fix this. I'm gonna set up my boom. This is basically what I want. Model view direction, my bias. So let me do a recency weighted average here. All right. Now instead of my model view direction, what I need here is my model position. Oh, interesting. Translate to camera position, the camera direction, the camera direction. Hold on, guys. I'm actually got confused what I actually did here. All right, so basically how that third-person camera works is I get my camera instance, I get my model position, then I get my model view direction, which is basically where my 3D game object is looking at. Then I translate the camera along the direction of the view direction of the model. So that's my new camera position. I get the Y offset for my camera, which is here. And having that new data, I translate my camera to that position. All right. Now what I want is my view direction to be more smoothly. So instead of using model position as it is being fed into the camera, I want to smooth that data out. I want to do my weighted average, which is what I want, right? So basically gonna do the same thing here. So do a recency weighted average, but instead of my model view direction, I'm gonna use my model position because that's the value that is I need to smooth out. And then I'm gonna get my new camera direction. I do not need this. And then I can erase this. All right, let's see if that works. Okay, so I do not want to reinvent the wheel again. So I'm just gonna go to my documentation and get my camera type and get my third-person camera type here. All right, so this is it. I'm gonna go to my Earth class. I'm going to my astronaut, and I need to include this header right here. That H. All right. Alright guys, let's see if this works. Let's build this. I'm actually very tired today. I had a, like as you know, I love to play soccer, and I usually play uh, soccer on Saturdays, and I had a game yesterday from 10 to 12. Uh, it was a very tiring game. I ran a lot. So I came home and ate lunch, and I had to sleep for a little bit because I was like done. I was like tired. Alright, so let me go over here. That's weird. What in the world is that? Oh, okay. Good thing that this happened. You see how the whole terrain looks, and how it looks distorted. And if you go to Blender here, right, it should actually look like this. So the problem with that is, and this took me a long time to figure out, because at first I thought that my game engine did not support a plane, and it turns out that the problem is that the scale needs to be normalized, right? And here it is not. So what I need to do is normalize it like that, and then I'm gonna export this again. It was funny because any other 3D object actually worked fine, except my planes. And I do recall that in the previous release notes that I had way back in like 2015 or so, I actually wrote that the planes are not supported. All right, so I have my character here, right? So as you can see, this is it. What I should do actually to make things nicer is change my view here, so we can actually see it better. Okay, so see my offset here. My offset, I'm gonna make it like around 2. All right, and this is my, I don't know, let's make it 7. Let's see if that helps. Oh man. Okay, so it's building. Let's see how that looks. All right. Okay, so everything looks good. Let's see if I can go. Let's see how it looks when I go up the hill. It's not that smooth, right? I wonder what should be here. You know what? We didn't do? We didn't compare both values. How it was working initially. So let me remove that to what I had initially before I made any changes, and let's see if there's any difference between them two. Alright, so we have that. Alright, so we have my terrain here. Let's see what happens when I go up the hill. There's a little bit of that choppiness of the in the camera. Oh great guys, guess what? Oh my gosh, my keyboard, don't tell me my keyboard is dead, seriously. Oh no, my keyboard is okay. I cannot type. Alright, perfect. Keyboard disconnect, and let's connect again. Oh, there you go. Wow, perfect. Connected. Okay, cool. For a second I'm like, oh. Alright, so let's think about this. Okay, so I'm gonna do a float bias and I'm gonna set it to 0.88, right? And then I do the accumulator, which is what I want, and then the accumulator per over here is times my bias plus what I want here is out of your direction. Minus bias. No, my model view position. Model view direction. Okay, well in this case, when I set my camera into view direction, it's basically I'm looking at the object itself. If I do it like this, basically I'm gonna be looking at what the character sees. Let's see what that, let's play around with that for a second. All right. Looking at the character. Okay, yeah, so here we are basically looking at what the character sees. Yeah, so that's not gonna work, and that's how it should be. Here should be my model position because I want to follow my character. What if I make the changes over here instead? Model position, accumulator, See, my mother position is what I'm actually storing with me, right? So then I will start accumulating that amount of position with every game tick. Then I translate the camera along that direction. That's my accumulator. And I keep storing that. And let's see if that works. Alright, I want to switch to my Mac screen. Alright, let's do this. Okay, that's my guy right there. Okay, I may need to change my bias because there's kind of a motion there. Let's see, come on guy. Okay. That kind of looks better. What do you guys think? So let's think. Okay, so my camera, what it follows is the position of my character, right? If there is a certain change in that position of the character, then my whole camera is gonna look choppy, a view direction. So if I smooth out the position over time, which is what I'm doing with my accumulator here, well, let's go to the extreme. Let's make this 5. All right, let's see what happens. Right. Let's see how you see that changes every time he changes position. Go back. Yeah, I see a problem here. Oh boy, what if we go to 99? How would that matter help? I don't want to make it 1. Model position, model position. All right, now let me go up the hill. I still see that choppiness. Ah! And everything looks weird after that. And in the other way how we had it before this, I don't think it helped that much either. Alright, so I'm gonna go back how I had it previously. My model view. My model view. Okay, I'm gonna go up. Huh. Well, where are you going? Where are you going there? Okay, I wonder what am I doing wrong here? Although to be honest with you, if we compare, you know what? Let me go back to my actual previous scene that I had, and let's see if any the problem that I have right now is that it's kind of hard to see the difference between the one and the other, between the original implementation and the new one. So I'm hoping that with this one I may actually get to see it. Alright, I'm gonna go up that hill right there, and let's see. I look kind of okay actually. You know what, guys? I think that the problem is actually more related to. Let me go over here. I'm gonna do this. Okay, I'm gonna go over here and then I'm gonna go up. The problem is whenever I come down the hill. Not so much when I go up the hill. Okay. Why is that happening? All right. I think I'm gonna stop my stream right now. I'm actually wanna go get something to eat. I'm hungry. and it's already noon. So before I leave, I end my stream. Basically, what I wanted to show you today and share with you uh, was is basically this little nice little equation that you can use to smooth things out. As you notice, whenever I used my first person camera, uh, it actually helped a lot with the smoothness. Um, and just to recap, let me bring that up again. Uh, Let me set up my first person camera and let me do this. Um, there may be some changes that I need to do for my third person camera. Um, I do not really know why the camera looks kind of choppy when the character is going downhill. All right, I'll think about it today in the afternoon. But basically, when you use that particular recency weighted average, um, it helps smooth out all of the your values that you want to. Basically, it's a weighted average. It's a nice little equation that you can use to smooth out uh, your a new output, right? In this case, what I do, I get all of my previous vectors or view directions of my camera, and I do a weighted average with any new uh, view direction. And instead of making an abrupt change in direction, that the changes are more smoothly and nicer, right? So here, I have my little demo set up to use a first person camera, and now whenever I go up the hill, you can see how it's so much smoother, right? And I can come here and I can come down the hill, and it's a lot smoother to go up and down, right? um, and that's basically what I wanted to share with you and show you. Now I know that it should also work with my third person camera, and I'm also pretty sure I'm actually doing something wrong in the implementation. But I'll fix that and share with you the whatever I find. All right. So uh, basically, guys, I'm gonna stop here. I hope you learned something today, and I'll see you next time. Now, um, you may have noticed that I'm really bad at my schedule, and there's a reason for that. Okay, so basically, I work on the engine either before I go to work, um, or let me restate that. The times where I can actually stream are basically before I go to work, and after I come back from work, um, and 90% of the time I work on the engines early in the morning and late at night after like 7 p.m. Well, I like to go play soccer. I like to go to the gym, and it's been hard to keep. It's been hard to come and do a Twitch every single time that I hope I could do one, because things happen. I have to take care of things, on and on, and sometimes tired. Come from work very tired. Last week I had a conference, and I was very tired, and I was so tired, and I mentioned this in my previous Twitch, that I actually went to sleep at 9:30 p.m. and didn't wake up until the next day at 7 a.m. And that is not me, because I usually go to sleep very late. My dinner time is usually at 11 p.m. So I tend to go to sleep like around midnight, around that time, and I wake up at 5:30. And that's my normal. That's my my normal sleeping schedule. Um, and last week, because of the conference, I was so tired. I couldn't really do any live streams. I did work on the engine, but it was like here and there. And the other reason why I don't go live every as much as I want to is because sometimes I have to think about how I'm gonna fix the problem. I have to, get my notebook and start like doing sketches of how I'm gonna fix that issue. And I don't want to come, go live and bore you to death, right? Me trying to figure out what's going on. Um, Yesterday was a good, it's a good example. I had no idea what was going on with the interpolation. I thought it was going to work in the beginning, but it turns out that none of my ideas actually worked. And I don't think you want to see me just like come think about different ideas and none of them work and this and that. So um, I want to make good use of your time whenever you join my channel. All right. So in summary, I've been very bad at following my own schedule. One, because of work. Number two is because sometimes I need to think of how I want to implement something, and once I have a clear idea, then I can go live and share what I learned. So I'm thinking that I may actually uh, bring down the number of times that I go live. I'm thinking that probably on Thursdays and Sundays would be good, um, instead of doing one week. I think I did a Twitch on Tuesday, Thursday, Saturday, and Sunday, and I think that was too much. Um, I love doing this. I actually like going live and doing a live stream. But sometimes I do need some time to think of what I'm gonna do, prepare, have a good idea of what I want to share with you. All right. So having said that, guys, I may actually go live sometimes on Thursday probably. If I do have something to share with you, I will send a tweet. So do follow me on Twitter. I will basically send a tweet letting you guys know that I'm gonna go live and that I have something to share with you. All right. Aside from that, thank you guys for joining, and have a good rest of your weekend. Thank you, guys.